Brexit your way out of here.
I don't Brexit. Does anyone else?
No.
Okay, I'm going to start now, if that's okay, because I actually don't know how long this talk will take, so I'm going to try to fit it all in. Is it okay if I start?
You're good, go.
Okay. So my talk is on the recommendation engine, but first I should say, since it's been 5 years since I've given a PHP talk, I should bring you up to speed about who I am. I'm a PHP software developer, obviously, or I was, since about 2000. Most of you in this room, but hopefully not all of you, haven't been programming as long, let's hope. My first commercial PHP website was an internet travel search engine. Just think of like Kayak, not Travelocity. Then I worked in Internet of Things. Back then there was no Internet of Things. It was just like X10 and RF and a bunch of video feeds and like you trying to get like an MMS made. That was in PHP also, and I worked on a virally tuned website that some people have heard of called Plaxo, and then a large social network in the United States. And I kind of got sick of doing evil, so I'm like, fuck that shit, maybe I need to do some good. So I worked on two open source projects you may have heard of, WordPress and Wikipedia. And that carries me up to 2014 when I was a PHP software developer. That's past tense, I guess, at least not recently. But somewhere in that mess, this happened. I was at OSCON in 2005, and Cal Evans, who is in the audience, I think, over there, he had just started working at Zen, and he came up to me he saw me sitting there, he came up to me to schedule a podcast interview. And when I was talking to him, I realized, like, why'd you come up to me? Like, I'm sitting right next to Wes Furlong, who's the king of Peckle, and Andrei Zameski, who was the lead developer of PHP 6 at the time, which, if you ever wonder why there is no PHP 6, now you know. And Cal started to pull out this deck of cards, of baseball cards, and start flipping through, like, looking for their faces. I'm like, whoa, what was that? Right? And I demanded he like fess up as to what it was, and it was a bunch of cards, and I'm like, wait, are those cards of us? So I made him cough up those cards. I took photos of it. I tweeted it. It became a meme that he got teased at Zend. This is my card right there. This is Andre, and that's Wes. You may not know this, but there's actually a pretty intense game of Magic going on there. That card right there is extremely rare because it's a misprint card. It has it's a George Sesnagel card that has Zach Grant on it. My card if you tap my card, you can you can call my profanity special power and cause the entire audience to get taunted for one turn. In the end, Cal did get his revenge, and I think around 2006, he was working at Zen. So when ZenCon happened, he made cards, a deck of cards with all these PHP developers on it, 52 of them. I was one of them. I found myself at the Four of Hearts, and I thought to myself, during the Iraq War, the U.S. military published a deck of cards of all the people all the terrorists they were hunting down. It has Saddam Hussein as Ace of Spades, so I'm not really high up on the terrorist watch list, or the PHP terrorist watch list, but that's actually how I became a PHP terrorist. The next year, Zend, through Cal, made a developer trading card set. That's my card, where they literally called me a PHP terrorist. You can see that. I'm apparently powered by the blood of young Ruby developers, according to the So what does that mean? Like, why Ruby developers? Well, we have to go back to that time, like why the blood of Ruby developers. And that year before was 2006, and that's the year of the dog. This was the year where there are tons of articles with like various titles like, is PHP doomed? You know, is PHP dead? Like, no one's coding in PHP. I don't know. And that's because that year, 2006, at OSCON, Danny O'Brien gave a keynote speech, just to give you an idea, where he was talking about Gandhi. And he pulled up this Gandhi quote, but we're tech people, so we can't really understand that quote. So I made a nice little state diagram for us. First say, I can't even read my own text, but you'll have to say, you know, first say, ignore you, then they laugh at you, then they fight you, and then of course you win. And his point was, unless you're Ruby on Rails, and in which case they ignore you and then you win. And I just have to say, like, I went to a talk on performance optimization, and there must be some killer XDebug to optimize that state diagram so well. At least a great port of XDebug for Ruby for them to have been able to do this. So that just gives you an idea of just like what hot shit Ruby was in that year. And the next year happens to be the year of the pig. That's the year I was born. Or rather, I wasn't born in 2007, I was born in the year of the pig. So it's my birth year. It's like my home territory. And I'm like, you know, fuck dogs, right? And it was the year where I asked, you know, if Ruby is the dog, you know, is PHP the dog food, right? And I just decided to update the state diagram from they ignore you to Ruby wins to another thing, which is I laugh. And, you know, because it's my territory. And this, I just noticed that this is the year of the pig. It is 12 years later. So I just thought, what the hell, why don't I go to TOB and look at their software rankings? So in 2002, when PHP was language of the year, it was at number 5 and Ruby was somewhere around 30. I can't go that far down the graph to figure it out. And then in 2006, the year of the dog, they were number 8. So you can see why they thought like, oh, PHP's dead. It dropped a single place. I mean, God forbid. And Ruby had like skyrocketed for nothing to number 8 and got language of the year. And today, this year, the year of the pig, it's at number 16. PHP's still somewhere around there, number 7. So that's a pretty sizable drop. So I thought I'd update the state diagram. I'm still laughing. So in 2007, that's also the year of the pig. What was the sort of things I was saying that was like getting me being called a PHP terrorist about Ruby? And I said things like Rails is a rounded rectangle and PHP is like a ball of nails. And there were actually like conference t-shirts with like balls of nails, like a photo of ball nails saying PHP development. And what did I mean by that? First of all, I should say like Rails is like that because it's a framework. I mean, I'm picking on Rails, but I could pick on all your frameworks. I don't care what frameworks you're using. It applies to all of them. They're beautiful. They're like rounded rectangles. Great. But when I mean PHP is a ball of nails, what I was saying is PHP is just this piece of shit that you just put together. You put all the parts together, and you just, you know, throw it at a wall and it fucking sticks to shit, right? So you don't have to worry, and that's what's great about it. And since this talk won't feature much PHP, I will be mentioning other things. I just need to translate that. I need to make a little translator to the 12-year-old self of Terry and say if in this talk when I say this, for instance, when I say Ruby or Python or Java, you should know that you can do it in PHP, of course. If I'm saying Ruby on Rails or Django, you can do it in whatever fucking framework you like. I have no idea what frameworks people are using. You know, maybe WordPress, I don't know. And of course, if I say something like NumPy or Pandas or some computationally heavy stuff, you can do it in R or MATLAB or just if there is a PHP numerical library. No, there isn't, but if there is, you can do it in that. It doesn't really matter. I mean, a lot of languages don't have these sort of things because they're not made by some crazy mathematician who loves Monty Python. Well, fast forward to today. I'm currently at Clara Health. Basically, what Clara is a patient-centric approach to connecting people to clinical trials. They're very small. I think I'm like the fifth employee there, fourth or fifth. I'm running engineering there. They're on actually Python and Django, which is, somewhat terrible, but I think it could be a lot worse. And it was a lot worse last year, or just, earlier, back when it was the year of the dog. My last company was Raise Me, and what they do is they help students earn money for college in the form of micro scholarships. Like by moving the financial aid process to before students even apply to school, they might apply to college that they wouldn't normally do, a college that they wouldn't normally do, and the college incentivizes them to become the sort of students that that college is kind of looking to fill. But their main web stack is actually Ruby on Rails, so that was kind of a lot of torture. But I really, really wanted to start developing, and this guy Dave hired me, and he features in this story. He's the CTO and co-founder of the company. He actually became the CTO and co-founder by answering an ad on Craigslist. And so I thought I'd share some facts that are relevant about him. First of all, he started as a consultant, and he was that since the late 1990s. So he's actually been coding longer than me. Before he was a consultant, he was in a rock band. You can actually download his music on Spotify. He quit smoking through the magic of CrossFit, which he won't shut up about. And the only thing he talks about more about CrossFit is Buffy the Vampire Slayer. In fact, he named his dog Buffy. These are important facts, believe it or not. You'll see. So in order to set up this story, I need to explain recommendation engine from the perspective of science fiction writer Arthur C. Clarke's 3 laws. What are these laws? I'm just not going to do them in order, but there will be 3 parts to this talk. Really, I'm over? No. The timer here is like really messed up. It's counting up instead of down. It's scaring the crap out of me. Which is the first law is when a distinguished but elderly scientist states that something is possible, he's almost certainly right. When he states something is impossible, he's very probably wrong. I didn't have a distinguished scientist at Raise, or a distinguished but elderly scientist at Raise, but I did have a distinguished but elderly CTO. And he said to me, Terry, I think it should be possible to recommend colleges to students in a manner like College Search currently did, where you like type in search engines and you like filter shit, but without the user doing any input, okay? And that was related to the first law, where he's very possibly right, or probably right. But he's going to take exception to me calling him elderly, so we'll cross that part out, because he's very spry because he does CrossFit. Like, you have to remember, he does CrossFit. In fact, he says I should take up CrossFit. Every one-on-one was practically like how I should do CrossFit. And it'd be impossible for me not to love it like he does, but thanks to Clarke's first law, we know that he's very probably wrong about that. So what is this thing that's going to do it? It's something called a recommendation engine. So what is a recommendation engine by which I speak of? Well, the definition on Wikipedia is basically a subclass of information filtering system that seeks to predict a rating or preference a user would give to that item. That's not very helpful to me because I'm an engineer. I kind of need it in engineering speak. So the way I look at it, I put it this way. A recommender uses analytical data as opposed to transactional data for a user-centric purpose as opposed to a business-related one. Let's understand what I mean by this. Let's take those words and put it in English. So the stuff on the left is stuff you are actually familiar with, and the stuff on the right you might not be familiar with. So on the left, a user-centric problem you might deal with is the user wants to log in, right? And to do that, well, a business-centric question they might ask is how many users logged into the website in the last 30 days? Like, this is a typical question some biz dude is asking you. It's usually a guy, but it, could be the other way. Who knows? But to answer the first question, the users that we usually service, it's a very simple one. We want to select user and password and their user ID from users where user email is such and such. And that's super easy. We do it in a database. It's a relational database, using MySQL or Postgres. And the terminology in this space is to call that thing an online transaction processor. So if you hear OLTP, that's what it just means database, at least databases that we know, which are typically relational. And that's like kind of the representation I'm going to be using for that, a disk. I don't know why, because it kind of looks like a database. If it's an analytical question, if we were to answer that using a relational database, this is the sort of query we would do. It's like select count star from users if we had, and join that against some sort of activity table that we'd have where that the timestamp for that activity data is greater than is in the last 30 days. And if you look at that sort of query and say, I want to do that on my relational database, you notice there's a count star, which really sucks. And there's also a select where on a thing that we would never bother to index. And that's kind of the issue with using like a traditional database to answer these analytical questions. There's just going to be like full table scans, and you're going to be like waiting forever, and it's a biz guy, so who cares? And so we want a database that's optimized for those sort of queries. And those databases are known as data warehouses. Or online analytical processors. So just so you understand, at Tagged back in 2007, when I was like ripping on shit, or at least Ruby, a typical database, actually the one we were using is called Paracel. That database is actually like a Postgres database. So the interface is simply Postgres. So the query there would like literally work on the database. So what are the differences? A regular database would have a row-based system with some relations. Paracel takes that database and it rotates it and makes it column-based. And then another thing, that makes it so that you don't have to index anything because all the columns are right there. It's effectively like an index. And the other problem is like if you wanted to scale out your database for transactions for users, you usually like partition by like user ID or something like that. To scale this database, it's already designed to be massively parallel, so you just add more nodes. Okay, and that way it can do like this count star and so do it across all of the units and then merge the data, so that's how you get your speed. If we were to do this on Amazon Web Services, the MySQL Postgres thing, we just use RDS. Well, actually, apparently Paracel is available on Amazon. It's called Redshift. It's the same product. It's just Redshift. And that's what I was using at RaiseMe. So one last thing I didn't mention is if you wanted to get your data off of that and onto your analytical or your data warehouse, you're not going to actually, you need those to be in sync. So how do you sync that? How do you get it off like web logs and your actual transactional database onto your analytical database? Well, there's a term for that. It's called an ETL. It stands for extract, translate, load. There are various ETLs. I'm not going to tell you which one to use. Just like use Google Foo, where you like have your database like Redshift. You type that in, you type ETL, and you type what your source is, and you find out who has some product or something for free, or you roll your own. Just know that ETLs exist. And finally, in terms of the recommendation engine, I just want to emphasize and remind you, we're taking analytical data, but instead of answering business questions with it, we're going to help the user. That is basically what a recommender is, in a nutshell. So I was working at ACDC, Awesome College Discovery Crew, that's what they named themselves. And I can just imagine Dave saying like, yeah, that's awesome because I'm a rocker. And this gets back to the purpose of that group. Its first was to improve student college matching. because our business, our revenue is related to whether a user follows and then goes to that college. That's how we get paid, right? But we also want to make the product more intuitive. So Raise wants to use that data that's going to improve that connection to also get more users to follow colleges and follow the right ones, the ones that they're actually going to go to, apply and go to. And just remember, these are the two quotes I had up earlier. The question is if Dave, who's a distinguished but elderly CTO, distinguished CTO, says that it should be possible, then he's almost certainly right? And indeed he is. Amazon's been doing it since the 1990s. Things like customers like you also bought. These items are frequently bought together, and even their homepage has recommendations on it now. A more recent and relevant example is Netflix, at least relevant to RaiseMe. It has buckets, like because you watched X, which would be equivalent to because you follow this college. Or popular on Netflix would be popular at your high school. As well as showing ratings of movies you might want to consider. Those are 3 areas they're using recommendations. In fact, once you see recommendations, you see them everywhere, whether it's Twitter, Spotify, or dating sites like OkCupid. So how's it actually built? Let's translate it to like get the pedal to the metal. The first iteration, the rec engine loads on the client side. It's like in React, and then it requests from the rec engine a list of buckets. Okay, and the rec engine gives that list back to Ruby, and Ruby just translates it into something that it sees, and then it says, hey, there's a bucket ID, and I want that bucket recommendations. So in this example, I want colleges in the West. Okay, so the bucket is here are some recommended colleges in the West because you're a West Coast person, or at least I am. And the server calls that, and you can see it gets the results in the bucket, okay, and then renders it. But let's look at that middle part where I just said some recommendations just happen and explode that. What is going on is the Ruby on Rails API to the JavaScript end basically has this bucket West. It has from the previous query what that West bucket actually means to go, and it ships that query onto the Go service. The Go service has to introspect that and see that there's a ranking part of that request, and that ranking is for student ranking. And so therefore it's going to use something called a collaboration filter, which I'll explain later. Some freaking like Python magic happens. It gets those rankings back. It filters that by colleges that are in the West. Because it has all colleges, it just filters that down. That's a very simple select join. And then it returns that to Ruby, which adds some, rips out some stuff and puts in some syntactical stuff so it looks nice and it renders on the client. So you may have noticed that there are 4 languages there. So why are there 4? Well, data science is Python, so that kind of makes sense, right? But Ruby, they use Ruby and Go. So Go for the service part, and they use Ruby for web development. But if you have Ruby and Python, what they were using Ruby on Rails, why weren't they using Django, which is literally, as far as I'm concerned, having coded in both, is identical. And I believe the answer, and I am a firm believer that I've been saying this for the last 13 years, is bad marketing. Rails just has way better marketing than Django. Now, before you object, imagine if instead of being called Django, the same framework was called Python on a plane. It'd be fucking awesome, right? So let's rewind to 5 years ago, okay? In an alternate Git timeline, our CTO, after having answered this Craigslist ad, goes back to his house in Fairfax to code the website, and he would have been like, in my only slightly less distinguished youth, but still spry youth, I was a literal rock star, so of course I would choose Python on a plane. Rock on. But alas, it's not called Python on a plane, it's called Django. So what happened in reality is Django is named after a French jazz guitarist, and younger Dave is like, jazz is not rock and roll, So screw that. In fact, after more research, he found out that Python was named after Monty Python, and that's not as cool or heavy metal-esque as a snake. In fact, Monty Python can't hold a candle to Buffy the Vampire Slayer. So he chose Ruby on Rails, which is far more heavy metal than a bunch of English comedians and a French jazz musician. And that is why I had to spend 2 weeks learning Golang. So, second law, or rather, part 2, Clarke's third law, because I'm doing it out of order. I'm sorry. You've heard of Clarke's third law, many of you. It states that any sufficiently advanced technology is indistinguishable from Magic the Gathering. I mean magic. So in this case, I showed you a place where Python magic happens. It was just this place where I just go recommendio collegia, and the results were there. All the results were, and then we just filtered them down. But we're programmers here, and we should be able to peel back that magic. So this is the quote. Let's look at the quote, and you might be asking the question, any sufficiently advanced technology is indistinguishable from magic? Really, is any advanced technology sufficiently indistinguishable from magic? More specifically, is Python sufficiently indistinguishable from magic? And I will prove to you for all time that Python is indistinguishable from magic. This is a true story. I have a non-techie friend who, when she first moved to San Francisco, she happened to be sitting next to two people who were at a restaurant, and they were talking to each other. And the first one goes, "What are you up to?" And the second one says, "I'm learning Python." And she goes up to them and says, "Excuse me, but I think it's called parcel tongue." And so clearly, Python is magic because they're indistinguishable, at least to her. I mean, she later worked at a tech company, so she figured it out and was very embarrassed by this. But at that moment, she couldn't tell the difference between Python and Harry Potter. So there you go. But we are engineers, so let's just explode this recommendation system. It's a two-parter, right? We've already discussed the second part. It's just a filter down. There are actually two ways to do this, to do the ranking system: a collaborative filter or a content-based popularity table. So let's just explain what those two are. So the first one, well, there are many types of rankings we could do. We could do a ranking based on similar students, like students similar to you did. We could do a ranking based on colleges, like because you follow this college or because you're viewing this page. We could do a ranking based on the state the student goes to, students in your state went to, or students in your high school went to, or students in your area, like your zip code, went to. And for the first one, the student rankings, you use a collaborative filter to solve this problem. And for the other four, we can just use a popularity table. So I wanted to show you what that looks like. First, for the collaborative filter. This is kind of what it might look like. This is a hypothetical list of page views of a student versus the college pages that they viewed. And you can see that there's, I could have used a different data set like follows, but I'm using these theoretical page views. And there are some empty spots where we don't know if the student actually wants to view that page or would actually view that page. So what we use is a technique called matrix factorization. And what that does is it's going to extrapolate this big matrix as the cross product of two other smaller matrices that we're going to generate. And that way we can figure out the missing values. I use NumPy and Pandas to do it, or I used. So let's see how it works. It's actually pretty simple. It's just some math. You throw it in the math box and shit comes out. So let's look at the first question mark I just highlighted. Those two students look nearly identical. So clearly, this matrix factorization is going to give me about 2 from that one. In this section, you can see these two students are similar, so it's going to give me about 4. And in these section, you just have to trust me. It's going to do something equivalent to about 1 and about 2. And now I have this entire preference. In fact, I can read out student B's preferences. Just remember that the bigger number means more popular, right, because it's page views. So it's college Z, then Y, and then X, then W. I can do that for D, I can do that for E. You get the idea, right? So I have those rankings. So how would I actually build it, or how did I actually build it? Well, once an hour, an EC2 instance of Python would actually talk to the data warehouse, and it would do its matrix factorization magic, and then it would send that, it would serialize that and send that, store that somewhere, the model of that entire matrix. That in Python speak, they call it, I can't remember what they call it. They call it pickling. It's the same thing as serializing. So if I had this request coming in for this student ranking, it goes to the Go API server, which because I'm lazy, instantiates a little Python, because I'm cheating here, just so I can deserialize that model and ask it, hey, what is this user's ranking? And then it just sends it back, no problem. Let's go back and look at another ranking system, the popularity table. It's the same thing, except you notice I added a column, the state column. Okay, so this is going to be like state, students in your state went to, or as popular as students in your state. Let's sort by that state. So same thing, I just sorted by the state. And now collapse them, add all of the ones in a given state, and we get this. And now we can read off California very quickly. It's college Y, then college W, then college X, and college Z in terms of popularity. Really simple. You don't need even a math library to do that sort of stuff. So what's the implementation? Well, once a day, because the ranks don't change as often as student ranks, we have a Python EC2 process, go to the data warehouse, and then it computes the new popularity table. But you don't want to query the data warehouse, so we have an ETL. Remember the ETL part? It drops it into an RDS so that we can just ask it later. So then this thing, instead of operating directly on the data warehouse, just goes in, asks the RDS in a simple query, boom, we send it back. Or we go to the next step, which is this content filter. Just really quickly, the design of this filter. Just a reminder, all it has to do is connect to RDS and do a join against the virtual table it created, and the table of, say, colleges in the West, and that would be the query, and it get back. But again, you don't want to be working directly on the data warehouse, and we can't work on our production RDS because we don't have a production RDS. Instead, we have something called, we return the result. We have something called MongoDB. So what you do is you use an ETL to get into the data warehouse, and you use another ETL to get into RDS and keep that all in sync. That's what ETLs do. This one's a commercial one called XPlenty, but it really doesn't matter. So finally, or part three, I don't remember. Clark's second law, or maybe it's Clark's third law. I don't remember. No, it is the last part, sorry. Thank God. What he said is the only way of discovering the limits of the possible is to venture a little way past them into the impossible. Whenever I see that, the words like venture into the impossible, I have to, I hear the music going, dun, 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 dun. Yeah, it's like Mission Impossible. So I want to say, your mission, should you choose to accept it, which I hope you do, is to build a more intuitive API using recommendations that I've shown you how to do. And remember, it's just a collaborative filter. It may have a collaborative filter, it may have a popularity table, it may have a context filter, content filter, or it could be any combination of the above. And even if you don't have access to a mathematical library or a data warehouse, you can do a lot of this just using those two and get pretty far. And I'll show that. And I'll do that by noting if it's Mission Impossible, there needs to be sequels. Before we do the sequels, I should tell you what the post-credit scene is of this mission. I'm going to show you a sequel, what I did at Clara Health in the 3 months I've been working there. And I'll talk about an old one, go back to the past, do a prequel. So the first one is what happened, a debrief of what happened. Well, because of recommendation engine, we were able to close our second round of funding in July. 15 million, that's pretty good. And then the next month, they disavowed my boss. And the month after, they disavowed me. So that's kind of a bummer. It sounds like pretty bad. But I like to look at the positive. If you want to work at a company, a recent company that has recently got money but has no senior engineering staff, I heard there's a company hiring, and I know it. And don't worry too much for me, because the very next month I started working at Clara Health as their head of engineering, so it's all good. Time to make another recommender sequel. I mean, that's what we do when we have Mission Impossible, right? It's completed 2 months later. And it makes a great example of how to build a recommender without using a data warehouse or a matrix statistical library. Basically, the problem is, we want to connect patients to trials. So they're going to be typing their disease in the site, and we have autocomplete, like cancer or ALS or something, and we have to complete it to the actual mesh term so we can do the search against the trials that have the real term. The problem, and you can just do this, you go to a Postgres like mesh RDS that has the medical terms in it, and you return the result, but you're doing a full text search, which is very slow, and you're only matching the text terms. You're not really matching terms that they actually want to look for. So let's say breast cancer, I happen to know, is the most popular cancer of all the ones that research is done. And where it's going to appear after cancer is like completely effing random, right? It's based on like some text match. If it has less characters or more characters, like that's going to determine it. And it also requires a large nested query to like handle all these like edge cases, like ALS needs to be expanded to whatever Lou Gehrig's disease is actually called. I don't remember. It's so difficult for me to say. Auto something immune something else. And we have to like bias that, so you have to like do all these nested queries so that they're sorted properly. And it still doesn't do a great job because it's missing breast cancer. So what did I do? Well, we're a Python shop, so I just use Lambda, AWS Lambda. Zappa installs currently. This is what it looks like, remember? So what I'm going to do is I built an ETL in Lambda. Lambdas are great for ETLs in Python. That just grabbed from there and from the actual clinical trials. And then it computed all of that. And I actually save it back to the database, which I didn't throw in this diagram. But then once it did that, it built a Elasticsearch thing with all the mesh terms. And I added, because Elasticsearch has autocomplete built into it, I just added a little bit of weighting based on the popularity of that. And now you just can make the query to Elastic Cloud, and it takes 1 millisecond, sometimes 2, because it's like a RAM-based thing. And I could improve the ETL later. I haven't done that. To use a different popularity, like for instance, actual terms that people are selecting when they're searching. I'd probably need a data warehouse for that last piece. So on to a past one. This is a prequel. Remember, it's Ghost Protocol because it's in the past. And it's Meet Me at Tagged. And the problem we were facing was that the site was only doing 20 million page views a day. That doesn't sound bad, you say. Well, it is when you have over 30 million users, or 40 million. I don't remember. It was a lot of users. And that means almost all the page views were the viral sign up. That was basically all the page views. So the 4 top people at the company each worked on their own Skunkworks project to improve user activity. And my idea dates back to something I discovered early that year. In May of 2007, I was invited to Facebook F8, and I was introduced to, like everyone else, to Facebook apps. And I was hanging out with a company that was had incubated out of our office. It's a company called Hot or Not, which you may or may not have heard of. And they had an app where they show you someone on your friends list, and you select whether you want to meet them or not. And it fucking bombed. I mean, it was terrible. No one used it. People were rather, like a friend of mine got drunk after he worked on causes, and he created an app where all you do is bite people. He called it Zombies, and then he asked me to bite all my friends, and that thing took off like hotcakes. And he only did that as an FU because he was saying when he was working on it that he worked at Plaxo, which I told you is evil, and he was saying when he's working on causes like Facebook's API is broken, I could go viral like in a second. And so he just did that to show that off. And that's how Zombies was created. But unfortunately, Meet Me failed really hard. And I had this theory that it's because Facebook's API is too limiting. I mean, who wants to meet only their friends? That just doesn't make any sense to me. You want to meet a stranger. So I was like, well, I can do that at Tag because I have a whole social network of strangers, 30 million of them. So that's what I started to do. But it's a different sort of recommender because you can't recommend your friends and you can't recommend people you might know, like friend of friends. That's what like all these other services like LinkedIn and Facebook currently do. So we have to be but we can't be random either. So you have to recommend someone you want to meet. So how are we going to do that? First, let me explain the architecture. It's PHP at tagged and an Oracle DB. So normally PHP, when it's doing its transactions, is writing to Oracle. That's cool. And I also had it write UDP packets of all the events off to a Java service that wasn't even written at the time. So it was sitting there. But later on, an engineer came and he figured out how to turn it into an ETL. He found a product called Paracel, which is Postgres, a commercial Postgres install of a data warehouse. And he figured out how to put all the data from both the database and these logs going into this big data warehouse. Now we have like everything. We have everything everyone's doing. We have a network mapped out. So what do? Well, you sign up for this app. You have to upload your photo to play this app. And when I say app, I mean a web app because this is 2007. So the iPhone was coming out this year, right? And apps don't come out until like 2009 or 2010. So you go and you say, I want to play, and the PHP service like starts up the app, and then it needs to make a query to get a list of potentials, right? So it calls this Java service to get this list of potentials, which builds this network, which already has this network of all these connections. And because like our friend list is very sparse, we have to use other data like where you're located or other preference data to like seed out and build out that, to make that network thing. And we hop around the network. What we do is this Java service will hop around that network 9 or 11 times until it lands on a person on the 9th or 11th or whatever. And when it does, we do that, if you know MapReduce, we do that millions of times. And then the reduce function is build a sorted list of that and keep the top 1,000. Okay? And then we cache that 1,000 and give the first 10 or so back to PHP, who does a little filtering because it turns out like we have a lot of people from the Middle East, and apparently they like California girls. California blondes, and you just the meet me on the other end is if you're a California girl who's blonde would just be seeing all these people from Iran and Saudi Arabia. So we kind of have to do a little bit of limiting so that it's more robust. That's just a content filter, right? And we just do the results, and if you need to do more results, it can pull it from cache. And if the cache is running low, that cache of 1,000 is running low, we just run this random walk again because you're just walking through the space, okay? And so how did it do? What was the result? Well, let me just say that I can't remember what the CTO, CEO, or the director of engineering skunkwork projects were, because when Meet Me launched, after the first week, we had just doubled traffic already. The average user was rating 200 people in a single sitting. By 2009, Meet Me, when I left Tag, Meet Me was doing 100 million page views per day. The site was doing 7 billion monthlies, and it became the third largest US social network, all because of Meet Me. And you might be thinking, that sounds familiar, rating a profile pic to meet strangers. Well, that's because my yearbook copied it and renamed themselves to Meet Me. And that same year, when they renamed themselves, a company Match copied them and created an app where you swipe left or swipe right, Tinder. And maybe I should be angry that like Tinder stole my idea, right? But just remember, Meet Me bought out Tagged anyway, so like they did whatever, right? And I shouldn't be pissed that Tinder copied my idea because I left even before there was an iOS app store, so like there's no excuse. I had no reason to have come up with this app because I was long gone. And remember, I stole the idea anyways from Hot or Not. So let's be honest, everyone steals from everyone, so it's totally cool. And besides, remember, I was done doing evil shit. So, it's no big deal. I'm not doing that stuff anymore. I did the social network thing. I need to do some penance here. So that's my talk. This presentation will self-destruct. But before it does, let's summarize what we've learned. The first thing we've learned is that building a recommendation engine is extremely possible, certainly possible, right? That's Clarke's first law. And then we learned how to build it. We learned to turn that magic into a sufficiently advanced technology that will actually allow us to build these things. That's Clarke's third law. And then finally, we learned that it's your mission to take this knowledge and build more intuitive UIs using the things I've given you. I've given you hopefully 3 examples of recommenders that I've worked on. And finally, and most importantly, yeah, Ruby still sucks. So thank you to SunshinePHP and you for letting me talk. Please go to this link and rate this talk. If you have any questions, just come to me afterward. Actually, I have a little time. I have 10 minutes, so I can answer any questions if anyone has. That's also a link to the slides. I'll try to upload an audio of the slides and other things when I have a chance. It's been so long, I don't know. And please do rate me. It really helps to feed my ego. I need that really badly because, yeah, thank you. That feeds my ego too, because then I knew you're a Ruby developer. Any other questions? Okay, yeah, you can clap. That feeds my ego too. Thank you. Oh yeah, if you want to add me on a social network, I think I'm on some of them. But when you do, say we met at SunshinePHP this year, and I'll add you back when I remember to log into those networks. I really do have no problem with you coming up to me and talking to me. If I seem cold, it's because I'm shy. It's not because I found out you're secretly a Ruby developer. I actually don't know who is. And I was for like a couple of years too. I mean, it was ugly. I smelled. I walked into the office in flip-flops. I talked about how great my avocado toast was. Yeah, it was a dirty time. But my code had rounded rectangles in it, so it's all good. Thank you very much.
All right, PHP karaoke.